Hello, this is Imre Lebic here, and in this video I want to give you a very basic fundamental tutorial on page loading speed, specifically in the context of SEO. The reason for that is because anytime I'm doing SEO audits for clients, I'm almost always seeing page loading issues. It's probably the most common issue I see. And also Google recently has been placing more and more emphasis and requirements on technical performance, so um, they've been coming up with new tracking metrics like cumulative layout shift, and before that they have core web vitals and probably have some more right now. So I think that the topic of technical optimization and page loading will be relevant in the SEO industry in the years to come. So what I'm gonna do, I will show you I will be placing different scripts and I'll be testing them and showing you how it impacts the performance on the final result of this score. Before I start, I want to give you a very basic explanation of how the browser works and how it loads the page. Essentially, the first and most important thing to understand is the browser itself is single-threaded. That means that it can only do one thing at a time. So it will do this thing, then if it comes across this script, it will download the script, execute the script, then proceed to the next one, to the very bottom, and then we'll just sum up the time for all of these resources and give you the final page loading speed. So you can see that this is my HTML document, and you can see it goes line by line. For example, we have the test.js. For some reason it skips the tag manager code, but then we have the bootstrap CSS, then we have the styles and mobile styles, which you can see here and here. So you can see that it goes line by line. Another important thing to understand is that the problem mainly occurs with JavaScript files. The reason for that is because JavaScript code can be either blocking or non-blocking. If you're not familiar with JavaScript, you probably don't know much about it, but I will try to give you very simple explanation. Here's a sample file that I created with two functions that both create a 5-second delay. Except in the first case, with this blocking for 5 seconds, it's blocking, it's synchronous. And this one is non-blocking. That means that the first one, for example, if I choose to execute this function, it's gonna mean that the browser will download homepage document, then it's gonna download the test.js, and then it's gonna start executing, which means it's gonna start waiting for 5 seconds, and it will not proceed until the 5 seconds are gone, meaning that it will block the rendering of the page. And this will impact the user experience because the user will not be able to see the page, see the HTML elements. I intentionally placed the test.js at the very beginning, right? And it's also going to impact the final performance score, the final loading speed and the final performance score of your website. Now, if the script is not blocking, if it's asynchronous, that means that whenever the browser downloads this file, it will start the execution, but the execution will happen in the background, and this is just the nature of JavaScript. And the browser itself will just proceed to rendering the CSS, the HTML, images, fonts, and the user will just see the page while that JavaScript will be executing in the background. So that means these 5 seconds will not be added to the final page loading result and to the final page performance test. So I'll be demonstrating that. Now, before I do, I also want to mention these two HTML tags, I believe, or JavaScript tags. They're called async and defer. And it's kind of a rumor going around that if you place this if you add this to a JavaScript code, these are somehow supposed to just increase your page speed by a few seconds because they are supposedly executing the script in the background. It's not exactly true. It's kind of a myth, and I want to really mention this before we start to actually performing the tests. So the important thing you understand that async and defer only control the dynamics of the script execution within that initial loading time, meaning that basically what async does in this case, it will whenever the browser starts downloading this file, it will do it in the background and it will proceed. But the moment this test.js is downloaded, it will start the execution and block everything else in case my script is blocking, right? So we're talking about the 5 seconds that stop the rendering of the page. So in this case, it will still add the 5 seconds to the final load, page loading result. Now, with defer, the only difference is that it will download this. It will actually just download and execute this test.js in the end, like to be exact, after the DOM and tree render trees are completed. But essentially, let's just say in the end, right? So what the browser is gonna do is skip it. Place it at the end in here. It will render everything. It will then download and execute test.js, which means 5-second delay. But this will still be counted to the final page loading result. So neither async nor defer do not actually reduce the loading speed of your site. And the most important thing is just whether your script is blocking or not blocking. There is slight advantage of using async, and I recommend that you specifically use it for scripts that are important for the page, like any script that actually adds some important interactivity. You should use async for that. And if the script is not important, then use defer and let it just execute after everything else is displayed. But again, none of those are actually gonna give you a better page speed performance in Google's eyes. Maybe a slightly bit here and there, because Google has multiple metrics how they track, but I'll repeat, there is not a very big advantage in using this. There is like milliseconds improvements, maybe a few hundreds of milliseconds at once. So I'll be demonstrating that right now. So we're gonna start with the first test, and we're gonna use the non-blocking script, which means that the browser will be loading this test.js immediately after the document, but the script itself, the 5 seconds, will be happening in the background and not be added to this. In here, I want to also emphasize that first test, I will not use async, and it should take a little bit longer to load. In the second test, I will use async, and it should slightly improve the loading speed. So let's just reset. Let's clear the cache just so we have fresh data, and now we're gonna reload the page. Here's the results. 124. Let's just look at the last number, the load. The final load of all the resources of the page, 1.63 seconds, right? Let's add async. Now again, this is not exact science because this may vary. If I try to clear the cache and refresh the page again, it will be slightly different. 134. All right. Now we're gonna add async. I'm gonna restart the website. Clear the cache. (134), slightly faster, a little bit like 200 milliseconds faster. Let's try again. Let's clear the cache. 196. Like you notice that async doesn't really make very huge impact on the loading speed. Let's use defer now. Reload the website, clear cache. And now 174. Another clear cache. 163. You notice that plus minus a few hundred milliseconds, it's just the same thing. So my script is non-blocking, the 5 seconds are not counted to the final loading time, and whether you're using defer or async, it doesn't really impact the performance too much. Now I'm gonna switch to using the blocking script, which means right now my page loading will be delayed by 5 seconds, and I'll start by using async. We're loading the website, clearing cache. Notice 1.6, 1.7, and now we're doing the blocking script. $7.54. You can see that now, normally it would have been 1.54, but now we have additional 5 seconds added. And now, just to be clear, that I've did some console logging here, so it's like rendering blocked for 5 seconds, rendering unblocked. So it's been this has been a 5-second delay, and it's been accounted to the overall page performance speed. So even though I have async, let's try to defer that. Now again, quick reminder, defer will just execute that at the very end. Clear the cache. $5.67 seconds. Again, even though that was executed at the very end, it just doesn't matter because the overall page speed is slow. Now let me get back to my non-blocking script, and let me just demonstrate you that the non-blocking script was actually in progress before. I will also do I have some console login happening. So watch, 1.9, and just to be clear, there's been 5 seconds counted, 1 second being one iteration being 1 second. Let's clear the cache again. Let's reload from the console page, and we'll see that how this script is executing. 1, 2, 3, 4, 5. So it took 5 seconds to execute the script. However, the page itself was loaded in 1.92 seconds. You can clearly see that the execution of the script was happening in the background, and it didn't block the loading of the page because this script is asynchronous. And now that this script was synchronous, it was adding 5 seconds to the loading result. Now let's look at this performance. This is my previous test, and this one is obviously using the non-blocking script, and you can see the performance is very high, 96, almost no issues, and just some slight tiny little issues here and there. Now this is the performance of my page with that blocking script. So you can immediately see there is 5-second delay added here, speed index 5.7. I have this issue here, and I have 3 recommendations caused by that delay. First, reduce JavaScript execution time. That's because my script is actually executing for the duration of 5 seconds. Second, minimize main thread work. This is because that execution is actually blocking everything else, meaning that it downloads test.js immediately. I mean, in case of async, it will immediately start the execution and stop everything else. And then it also impacts this metric, largest contentful paint image, like the last big image, because it, like the final result of the page, is also delayed. So 5.1, 5.26. I want to rerun the test live so you can see how it works. So right now we're using a non-blocking async configuration. I'm gonna click rerun. Mobile is a little bit low, but let's just focus on the desktop. Again, no issues at all, and just tiny little delays like 19 kilobytes, just a milliseconds here and there. Overall, very high performance. Now I'm switching to the blocking script. And I'm gonna rerun it here. You can probably notice that it even takes more time to actually analyze the page. I think I didn't do something because it's too... Did I reload the site? Something definitely went wrong because that's not possible. That could be the 96 score with the blocking script on. Okay, here we go, 36. Now, for a quick comparison, 96 performance score with everything passing the bar. Here we have the desktop performance of 36, almost everything failing, like 3 out of 5 failing the bar threshold. And again, let's look at the issues. Reduced JavaScript execution time, 5 seconds. The script is running and blocking everything else. Minimize main thread work. A single threaded browser, like doing one thing at a time, is busy running the JavaScript code and is not able to proceed with the rest of the resources of the page. And then as a final result, it delays the largest contentful pane image for 5 seconds. Should have been 1.15 milliseconds instead of 6 seconds. So I hope this demonstrates you that it's not really about adding async or defer to your script. It's about whether that script is synchronous or not synchronous. So with that being said, here's the list of some of the common scripts. Like not all of them, but some of the most common scripts people will be placing on their pages. And whether they know it or not, that may potentially be blocking and the page loading and reducing the final page loading speed. So here are some of the non-blocking, like Google Analytics, free to add, lazy loading libraries, deferring images and videos. Deferring essentially, lazy loading is essentially making a resource load only when you scroll to that image or video. And then caching plugins are safe to use on your pages. They will not increase your page loading. Now, what is going to increase your page loading and slow your site? Well, I guess Tag Manager is not really gonna do that. Technically it's blocking, but it's very fast still because it's made by Google. So I would probably not be concerned about Tag Manager. Now, SEO plugins, Yoast, 101, WooCommerce plugins, dynamic ads, page builders for sure, Divi element or whatever you're using, those gonna be adding JavaScript that executes and it blocks the further rendering of the page. Ad scripts, security plugins, video embeds unless they are lazy loaded, image carousels because they are made with JavaScript, obviously single page applications, etc. I'm just gonna link this table, add the link somewhere. Yeah, that's gonna be it for the video. I hope it makes sense and I hope I was able to clearly explain how the page loading works and what factors actually impact the final SEO performance and what factors really don't matter. If you have any questions, feel free to let me know, and have a great day.